In this video, we'll discuss a proven approach to optimizing the utilization of compute resources in edge data centers by offloading the virtual switching function to a programmable smart network interface card. We'll start by reviewing some of the unique constraints faced by edge data centers. Then we'll explain the technical benefits of vSwitch Offload. And finally, we'll analyze the implications of vSwitch Offload in terms of both the CAPEX and OPEX savings that are achievable for a typical use case. We'll also show you an online tool that you can use to estimate the benefits of this technology for your own specific data center scenario. So, driven primarily by latency-sensitive use cases such as virtual RAN, IoT, Secure Access Service Edge or SASE, and Multi-Access Edge Compute or MEC, service providers and data center operators are increasingly deploying compute resources at the edge of the network. And edge data centers are completely different from the massive cloud data centers owned by the hyperscalers, with seemingly infinite compute and storage resources. Edge data centers are physically small, with very limited power and a small number of servers. They operate under severe cost constraints, and the operators are under pressure to ensure that their edge data centers are as cost-effective as possible. One factor that's key to the return on investment for an edge data center is the utilization of its server compute resources. Each server in the data center's racks will typically have either one or two CPUs, like an Intel Xeon processor, and these CPUs have to run three very different kinds of workloads. First, they run the applications, which are the reason that the data center was deployed in the first place. Second, they run some kind of virtualization management system, which in a multi-tenant edge data center will typically be something like OpenStack or Kubernetes. And finally, they have to run a virtual switching function, which is used to connect virtual machines or VMs with both virtual and physical networks. And in many cases, a vSwitch is also required to connect east-west traffic between the VMs themselves. And it's really important to note that the applications are the only one of these workloads that generates any revenue for the data center operator. Everything else is overhead, consuming power while taking away compute resources that otherwise could be allocated to generating more revenue. So there's a strong business incentive to minimize the resources consumed by the vSwitch and the management function in order to maximize the resources available for VMs. And the best way to free up CPU cores from being consumed by virtual switching is to offload that vSwitch function to a programmable smart network interface card, or SmartNIC, running suitable virtualization software. In this example, the starting point shown on the left is a server configured to use part of its host CPU for running the open source Open Virtual Switch or OVS, and the server is also equipped with a standard NIC performing the usual networking functions. But the CPU cores that were used to run OVS can be reclaimed to run VMs by offloading OVS to run on a programmable SmartNIC. This is the solution that Napatech offers. Now, the easiest way to measure the benefits of vSwitch Offload is to look at the number of VMs able to run in the host CPU, otherwise known as the VM density. And this diagram compares two different implementations of an edge use case deployed on a server with an Intel Xeon CPU that has a total of 16 cores, which is a pretty typical platform for an edge data center. On the left, the implementation that uses a standard NIC has to run the virtual switching in software using OVS DPDK. 8 cores running OVS are required in order to switch the traffic that is consumed by 7 cores running VMs, with a single core dedicated to the Virtual Infrastructure Manager or VIM. So the VM density is 7 VMs per host CPU. On the right, we can see the benefits of offloading the OVS fastpath processing to a programmable SmartNIC running Napatech's Link virtualization software. Only a single core is now required to run the OVS slow path. And with one core again dedicated to the VIM, this leaves 14 cores available for VMs. And so the VM density has doubled. And for the same use case, we can actually get an even greater improvement in VM density by leveraging a SmartNIC with an onboard Xeon-D processor, again running the Link virtualization software. In this scenario, not only the OVS fast path, but also the OVS slow path and the VM are offloaded to the SmartNIC. All 16 of the host CPU cores are now available for VMs, so the VM density now improves by 2.3x compared to the original implementation using a standard NIC. And this is the ideal approach for bare metal use cases, because the host CPU is completely available for virtualized workloads, and there's no operating system or hypervisor running on the host. And these increases in VM density result in very significant improvements in return on investment, or ROI, for the operators of edge data centers. And Napatech has developed a tool for modeling the improvements in both CAPEX and OPEX for whatever use case scenarios that operators want to explore, based on a variety of assumptions about the use case itself, the CPU, the servers, and the data center, as well as the financial models that are applicable. So looking at the first scenario with a 2x improvement in VM density and putting all the relevant assumptions into the model, this results in estimated reductions of 33% in CAPEX and 50% in OPEX over a 5-year analysis period. And those are very significant reductions from the point of view of an edge data center operator. Of course, your mileage will vary, and the ROI benefits that you achieve will depend on the details of your use case. So Napatech has made this ROI modeling tool publicly available on your website. You're invited to click the link at the bottom left, fire up the tool, and evaluate your use case without anyone having access to any of your proprietary information. The tool is straightforward to use, but if you need any assistance or advice, well, then there's a button you can click to request help from an expert at Napatech. This is a pretty easy way to make a quick estimate of the CAPEX and OPEX savings that your edge use case could achieve by offloading virtual switching to a SmartNIC. So, in this short video, we've explained how offloading the virtual switching function from the host CPU to a programmable SmartNIC can result in major ROI improvements for edge data centers. Please do contact Napatech for more information and to determine the specific benefits that your edge use case could achieve thanks to this technology. Thank you.